This video is about multiplying rational expressions. When you multiply rational numbers, you can multiply across and get the answer. Now, before you multiply across, we can actually cross cancel instead of multiplying across and then canceling or reducing the fraction. So for instance, if we look at two rational numbers, we can reduce or cross cancel. So 2 can go into 12 6 times, where 2 can go into 2 once. So 2 twelfths is the same thing as 1/6. Then you can multiply across, which you have 5 and 18, 5/18ths, instead of 10 36ths. So when you multiply rational expressions, you do the same thing, except you will have to factor. Factor all polynomials. Then you're going to cancel a term or factor from the numerator and denominator. So let's start out with a simple x plus 3 over x minus 2 times x plus 4 over x plus 3. These themselves are one whole term. X plus 3 is one term, x plus 4 is one term, and so on and so forth. And you can place these in individual parentheses to kind of keep them together. And you can see that we have x plus 3 in the numerator and x plus 3 in the denominator. So x plus 3 divided by x plus 3 is 1, or they cancel out. And just as if we were to write this 12 as a 6 and a 2, and this 2 as a 2 and a 1, and we can cancel the 2's out, leaving us with a 1 and a 6. We are left with two factors, one in the numerator, one in the denominator, and we are simplified. X plus 3 over x minus 2 times x plus 1 over x squared minus 9. Now when we factor the trinomials or binomials or whatever the case may be, you can rewrite the whole problem out to the side and then write the factored form. Where in this case, we only have to factor this denominator. So I'm just going to put the factors right underneath and cross out the original one. This allows me to be efficient, and I don't have to copy the problem down 50 million times. The x plus 3's cancel out. And then we have x plus 1 over x minus 2 times x minus 3. Do not multiply this. Do not multiply or FOIL. Okay, so leave everything in its factored state and you will be fine. Now, do not cancel the x's out. Okay, the x's do not cancel because we actually have x plus 1. We have an x minus 2 and an x minus 3. So nothing else can factor or cancel in this sense. X squared minus 4 over x squared minus 1 times x plus 1 over x squared minus x minus 6. So we have 3 polynomials to factor. This one is already factored, or it's in its prime state. So what you can do is place the factors above and below, or you can rewrite your whole problem out to the side. It does not matter. I typically write them above and below. Sometimes in this sense I will go ahead and write them out, and I'll do that for you for this one. The x squared minus 4, that's a special factoring, a difference of 2 squares. And then this is another difference of 2 squares. And then we have x plus 1. And then this bottom one, we will have 2 factors. And then we'll have a factor of negative 3 and positive 2 for that to work. The x plus 1s cancel out. The x plus 2s cancel out. And then you'll have x minus 2 in the numerator, and then you just squish these two side by side, or any factors you have side by side in the denominator. And you can have multiple factors in the numerator as well. Now, with these type of problems, the most tedious thing that you will be doing is factoring. Once you factor everything, then the problem, you just cancel. The canceling parts are the really easy part. The most tedious is the factoring. So if we look at this factoring, what we're going to do is factor both of these denominators. And again, since I only have 2, I'm going to just factor them where they are, so I don't have to worry about rewriting anything. So we have x minus 3 and x plus 1. And at this point you should know how to factor really well at this point. So the x plus 5's cancel, the x plus 1's cancel. Everything cancels in the numerator, so we will have a placeholder of 1. Or essentially, since these canceled out, we just have 1 times 1. And then we have x minus 5 and x minus 3. Six x plus 6 over x plus 9 times x squared plus 6x minus 27 over 6x plus 6. So right away we see 6x plus 6 in the numerator and denominator. There's no need to factor those since they are the exact same, so we can just cancel those out. And then we will factor the numerator. And then that makes the x plus 9's cancel out, and we have x minus 3 remaining. Okay, we're going to go ahead and factor each of these. I'm going to place my factors above and below where they are needed. So this first one is x minus 5 times x minus 5. The bottom one is 10 times the quantity x minus 10. And then the last one is 9 times 5 minus x. Okay, so the x minus 10s cancel. And then these two are almost the same. In order to make these the same, we actually need a negative 5 and a positive x to cancel. To do this, we can factor out a negative. When you factor out a negative, our signs change. So this will be a -5. So if we factor this out, I'm going to do a little side work here to show you. If we factor out a negative, our 5 becomes negative and our x becomes positive, or we can just switch those around. That's the only time we can switch our values around without bringing the sign with us, is if we factor out a negative. So that's the only time you can switch those around, factor out a negative. Now we match up, and our answer will be x minus 5 divided by 10 times -9, which will be -90. So we didn't need that one anymore because we factored it. So we have a -9 and 10, which create -90. That -90 can stay in the denominator. You can place it way out to the side, or you can, oh, that's supposed to be positive, sorry. You can place it all the way out to the side, or you can put it in the numerator, but make sure that the parentheses are still around the x minus 5. If you distribute that through, you can actually write this as 5 minus x, but this will be fine for now. So either one of these ways is correct. So if you have 5 minus x, you can factor out a negative and make it x minus 5. It's a little trick. This concludes this video.